All right, let's go over some questions and answers on hydraulic reservoir. What is the main function of hydraulic reservoir? The main function of hydraulic reservoirs is to store hydraulic fluid and supply it to the pump. Name two additional functions of a reservoir. Allows for fluid expansion and helps dissipate heat. Why must a reservoir have extra space above the fluid? To allow for thermal expansion and air separation. Why is air separation important in a reservoir? To prevent air from entering the hydraulic system. What are the two main types of hydraulic reservoirs? Pressurized and non-pressurized. Where are small vented reservoirs typically used? Small or low altitude aircraft. Why are pressurized reservoirs used? To ensure positive fluid flow to the pump and prevent cavitation. What is the common method of pressurizing a reservoir? Engine bleed air or compressed air? Number 9. What is the purpose of a standpipe in a reservoir? Prevents total fluid loss to critical systems. Number 10. What is the function of a baffle inside a reservoir? Reduces fluid sloshing and foaming. What does the filler neck and cap include? A filter strainer to prevent contamination. What is the purpose of a flight gauge? To check fluid level, the sight gauge. What is the temperature indicator used for? Monitoring fluid temperature in the reservoir. Question 14. What could happen if a reservoir is not properly pressurized? Pump cavitation and loss of system pressure. Why is a reservoir designed to allow contaminants to settle? So contaminants can be removed and not recirculated. How does a reservoir help cool hydraulic fluid? By allowing heat to dissipate through its surface area. What happens if What happens if the reservoir runs low on fluid? Air enters the system causing erratic operation or failure. Why are some reservoirs pressurized with nitrogen instead of air? To prevent moisture and oxidation. Some questions. Some more questions from the prep guide. What device in the hydraulic system with a constant delivery pump allows circulation of fluid with no demands on the system? Pressure regulator. A fully charged hydraulic accumulator provides B. A source for additional hydraulic power when heavy demands are placed on the system. A hydraulic system referred to as a power pack system will B. Have all hydraulic power components located in one unit. An O-ring intended for use in a hydraulic system with MIL 5606 base fluid we mark with a what? A blue dot? One or more white dots? Or white and yellow stripe? It will be marked with a blue stripe or dot. A filter incorporating specially treated cellulose paper is identified as a micronic filter. Here's a good one. Which of the following is most commonly used seal to prevent internal and external leakage in both directions of a hydraulic unit? O-ring. Which of the following allows fluid to flow unimpeded in one direction, prevents fluid flow in the other direction? Check valve. Now, a check valve is a fluid power system component that allows free flow of fluid in one direction but prevents any fluid flow in the opposite direction. This is from chapter 12. Select the valve used in a hydraulic system that directs pressurized fluid to one end of the actuating cylinder and simultaneously directs return fluid to the reservoir. This is going to be a selector valve. Now remember, a selector valve is a fluid power system component that directs the flow of a pressurized fluid to one end of the actuating cylinder and simultaneously directs the return fluid to the reservoir from the other end of the cylinder. So those are some of the questions. We talked about pressurized reservoir, and we talked about non-pressurized reservoirs. So let's summarize reservoirs before we move on to the next session. Now, hydraulic reservoir is a component that stores hydraulic fluid and supplies it to the pump. It also performs several critical, listen now, functions. It stores fluid to the system. It supplies fluid to the pump in all conditions. It allows for thermal expansion and contraction. It helps remove hair, dissipates heat, and provides a place for contaminants to settle. Now we have two types of reservoirs, a non-pressurized reservoir and a pressurized reservoir. Now the non-pressurized reservoirs open to the atmosphere and used in small or low altitude aircraft. A pressurized reservoir uses air and nitrogen and ensures positive flow to the pump, and it prevents cavitation at high altitude. Now let's talk about the key components. Standpipe maintains fluid for critical systems of level drop. Baffles prevents sloshing and foaming. Filler cap and strainer prevents contamination during servicing. Sight gauge indicates fluid level. And if you have an installed temperature indicator, it monitors fluid temp. So, there we go. Let's move on to our next system. We're going to talk about from chapter 12. Y'all ready? Let me get the aviation maintenance handbook. I hope y'all doing all right this evening as we continue our studies from chapter 12. Chapter 12, one of the smoothest chapters. Hydraulic fluid. All right. Let's talk about filters. A filter is a screening or straining device used to clean the hydraulic fluid, prevent foreign particles, and contaminating substances from remaining in the system. If such objectionable material were not removed, the entire hydraulic system of the aircraft could fail through the breakdown or malfunctioning of a single unit of the system. The hydraulic fluid holds in suspension tiny particles of metal that are deposited during normal wear of selector valves, pumps, and other system components. Such minute particles of metal may damage the units and parts through the which they pass if they are not removed by a filter. Since tolerances within the hydraulic components are quite small, it is apparent that the reliability and efficiency of the entire system depends upon adequate filtering. So we're going to cover micron type filters. We're going to cover maintenance of the filters. We're going to talk about filter bypass valve, filter differential pressure indicators. Then we'll move on to pumps, hand pumps, power-driven pumps, constant displacement pumps, gear-type power pumps, the different classifications of pumps, generator pump, piston pump, vane pump, variable displacement pump, We'll continue on. Then we'll talk about valves, selector valves, right? We'll get deep into valves, check valve, orifice type check valve, sequence valves, pressure controlled sequence valve, mechanically operated sequence valves, priority valves, quick disconnect valves. Then we'll talk about hydraulic fluids, pressure control valves, release valves, We'll talk about pressure release valves like system relief valve, thermal relief valve, pressure regulators, shuttle valves, accumulators, types of accumulators, right? Spherical, cylindrical operation. Then we'll talk about heat exchangers, actuators, linear actuators, rotary actuators, hydraulic motors, ram air turbine, right? Power transfer unit, hydraulic motor generator, seals, V-rings, U-ring, right? O-ring, backup rings, gaskets, seal materials, wipers, O-ring installation. Then we'll talk about large hydraulic systems. We'll continue on the large hydraulic systems. Landing gear transfer unit, standby hydraulic system, indicators. We'll talk about the 777 hydraulic system, the different pumps, the indicators, the filters. And then we'll continue on with larger hydraulic systems, and then we'll end the chapter. So we'll continue tomorrow more with more questions and answers. Thank you for joining your study of the FAA Chapter 12, Hydraulic Systems. Peace.